When we name ionic compounds, those main group elements are just simply named for the ions that we stand for. Say the name of the element. Positive ions do not get changed. We just simply say the name of the positive ions. And if I write PT, you'll know I mean periodic table. So main group cations, the sodium ion, Na+, we're just saying the name of the element and we put on the word ion to let you know it's charged. K+ is named potassium ion. Ca2 positive, calcium ion. Mg2 positive, the magnesium ion. Say the names of each ions and then we'll give the symbols. So just as a reminder, if we have positives, we just say the names. But let's make a note here about the negatives. That's where I want us to remember that we change the ending to IDE. Alrighty, so let's try these now. S2 negative. Well, the element's name is sulfur. Sulfur becomes sulfide ion because I'm changing the ending to "ide" for the negative ion, sulfide. Letter B, I see Cu+1. Now remember this? This lies in the heartland of I don't know your charge by where you live. So remember, these are all requirements of the Roman numerals because they have a variable charge. So this is allowing me to kind of emphasize, I have to remember if it's a fixed charge, no Roman numeral. All the column +1s, no Roman numeral. All the column of +2, no Roman numeral. I know aluminum's a +3. I know that, no Roman numeral. And zinc, cadmium, and silver, we wrote in our notes as exceptions to the Roman numeral. Copper lives in the heartland of, I don't know what your charge is, so I have to tell you in its name. Notice this is called copper 1, and I'm going to put that in a parenthesis to let you know it's carrying a +1 charge, copper 1. Here's CS, that's cesium. Cesium lives in a column where I definitely know its charge. It's always, always, always a +1. So no Roman numeral because I know its charge. CESIUM, cesium ion. Not a variable charge, but a fixed charge. Roman numerals are needed for those metals that have a variable charge. Roman numerals are not needed for those ions that we know have fixed charges. The +1s in column 1 are fixed. The +2s in column 2 are fixed, no Roman numeral. Aluminum is a fixed +3, it never varies. Zinc, cadmium are always +2s, that's a fixed charge, just as silver is a +1. Cesium has a fixed charge of +1, no Roman numeral. Just like aluminum, we're going to just say the name of the ion, aluminum, and let you know it's carrying the +3 charge with the name aluminum ion. I called it iron. And SN stands for tin. Tin also has a variable charge. It is not found in the first family where fixed charges. It's not found in the second family of fixed charges. It's not aluminum, zinc, cadmium, or silver. So therefore, it has a variable charge. All the metals, you know, as you did this little staircase here, all the metals up until the world of the, you know, the border, when you hop over to the negatives, they have a variable charge. So I have to label that as tin 4 ion. Let's keep going. This one is called stannous. And did you know that stannous is actually the name here for tin, SN? Now if you didn't know that, I think that's okay. We used a Roman numeral to kind of help us with those names, but we did kind of have a chart, a few pages back that gave us those variable names. I was just trying to scroll through here to see if we could find those. all the little Latin names for the elements there, for the transition elements there. I don't see it. But anyway, stannous is tin. And so as I come here, I'm going to name this as tin. And then since I'm just reminding us that the lower would have the OUS ending, this would be SN plus 2. Stannic with the ic ending would be SN plus 4, representing the other possible charge on tin, tin 4 ion. All right, iodide. Here the ide, now I know it's negative. That comes from the element from iodine. Being in group 7A, we understand that it gains 1 electron, so it becomes I negative 1. Manganese requires a Roman numeral, so I put a little asterisk there. Let's do manganese 2 ion. See, manganese lives in the heartland of, I don't know your charge by where you live. You have a variable charge and thus requires the Roman numeral. So I'm letting you know this little parenthesis tells me to carry a plus 2 charge known as manganese 2 ion. The elemental symbol for lead you find here is I'm circling Pb, and the charge comes from its Roman numeral. That's lead with a plus 2. Here the ending of ide, that lets you know it's negative. Selenide, that's the elemental symbol Se. See where it lives in group 6A? Just envision what that means. You have 6 valence electrons. It has room to gain 2 more to become a noble gas configuration, and thus it ends up as a negative 2 charge. Let's name each of these binary ionic compounds. I would encourage you to pause the video and work ahead. Try these out. I put a periodic table here for your convenience so you can find the names of the elements. Remember, the last ones end with "ide," and double check. Does the metal require a Roman numeral? So that's kind of the last thing we check. I'm going to write that note here for you. Does the metal require a Roman numeral? And to answer that question, Roman numeral, there I got it, spell it right. It does not get a Roman numeral if it's in the first column. Those are always plus 1s. It does not get a Roman numeral if it's in the second column. That's plus 2. Aluminum does not get a Roman numeral. It's always plus 3. Zinc, always plus 2. Cadmium, plus 2. Silver, plus 1. Every other metal that's to the left of this border, right? Those are always the metals to the left of that highlighted border I just made, require a Roman numeral in its name. And the Roman numeral is coming from the charge that it carries. So let's practice. Give them a shot. Come back with the video when you want to check. All right, letter A, Na. Na stands for the element sodium. So highlighted right here, sodium. Does sodium need a Roman numeral? And the answer is nope. It's in column 1. It has a fixed charge of plus 1. The element fluoride, well, F stands for fluorine. We hear the ending change for the negatives, sodium fluoride, NaF. MgO is the letter B. Mg is the element magnesium. No Roman numeral. It's in a fixed column of plus 2. So just naming that as magnesium, no Roman numeral required. The symbol O comes from the element oxygen. We end it with oxide, O-X-I-D-E, for the binary compound ending, magnesium oxide. How about Sr, Br2? Sr is the symbol for the element strontium, located right here where I'm circling in group 2A. That's a fixed charge of a plus 2, so no Roman numeral. Strontium. Br over here in the halogens, group 7A, changing bromine to the ending ide, you get strontium bromide. Elemental symbol Li stands for lithium. Lithium is in a fixed column of +1, no Roman numeral. The elemental symbol O is oxygen. Changing its ending to ide, we get lithium oxide. Letter E, Ti. Now look where Ti lives. It lives in the heartland of I don't know your charge. This is a variable charge. So now I find finally an example where a Roman numeral is going to be required. The first name is titanium, but part of its name is a required Roman numeral. And let me just kind of leave space and we're going to work out the charge that it carries. And I wanted to emphasize, very critical, that the charge, not how many you have, but the charge goes inside the parenthesis. A common mistake a beginning student might make is looking at this subscript as a 1 and wanting to put a 1 inside the parenthesis. It is not telling me how many I have, but rather the charge that it's carrying. We have to play detective to figure out its positive charge. And to do so, find the negative ion that it's attached to. You see how that's an oxide? And because oxide lives in group 6A, remember what that means? 6 valence electrons. Oxide wants 2 more to become a noble gas. So when it gains 2 electrons, we know it's a -2 charge. Now think about an oxide, a -2 charge. And there's 2 of them in that formula. So we have 2 separate O -2s. That's a total magnitude of a -4. Our titanium has to carry a +4 charge to electrically balance 2 units of a -2. Titanium 4 oxide. Let me kind of stress that another way. Titanium was a +4, oxide was a -2. When we originally crisscrossed and would bring those charges around and down, we noticed we had Ti subscript 2 with O subscript 4. A formula unit, which is that basic building block of ionic compounds, right? That's called the basic building block. These must be in the lowest whole number ratio possible. In order to be correct, they must have the subscripts in the lowest ratio possible. So instead of having a 2 and a 4, they simplified that by a 1:2 ratio. It's still named titanium 4 oxide because that titanium's magnitude of charge is +4. Okay, that was a good one. TiO2, properly named titanium Roman numeral 4 oxide. One more in that set you wanted to check with me. Al, well, that's the element for aluminum. Aluminum, there, I spelled it right. Does aluminum require a Roman numeral? And you answered no. It's a fixed charge of +3, so no Roman numeral. We named that simply aluminum chloride. How'd you do? Oh, you'll get better and better with repetition. Here's some more. Pause the video. Don't cheat yourself. Pause the video and come back to check. I can see, boy, the vast majority, if not all, are going to require Roman numerals. These are transition elements written first. All right, letter A. Letter A stands for the element chromium. I know chromium lives in the heartland of a variable charge, so this requires a Roman numeral. The variable charge can be determined by the negative ion it's attached to. Chloride is a -1. right? So just think about what that means. We had CrCl3. If chloride is a -1 and there's 3 of them there, visually, do you see what that means? 3 units of this -1 chloride. We have just 1 unit of chromium neutralizing. It takes 1 +3 chromium to electrically balance 3 units of the -1 chloride. So what is the chromium charge? It's 3. Remember, this subscript is not the purpose of the Roman numeral. It's not how many you have, but it's the charge that you carry. Chromium must have been a +3 to neutralize chloride's -1. That's called chromium 3 chloride. We'll keep practicing. Here's letter B. Letter B, I see the element Pb. That's the elemental symbol for lead. See it right here? Pb. Lead lives in the heartland of having a variable charge. It requires a Roman numeral. So I'll leave a parenthesis as part of the name. The element S is sulfur. Ending in the IDE, you hear that called sulfide. Notice we have, just playing detective, we have to figure out what is the positive charge on lead that's balancing the charge on sulfur. Sulfur lives in group 6A, right under oxygen. So remember, that means it has 6 valence electrons. When it gains 2 more to become like the noble gas argon, gaining 2 electrons makes it a -2 charge. So what must the charge on lead be, knowing that we have a 1-to-1 ratio? If sulfur is a -2, and there's just 1 of them, lead also has to balance with a +2, and we have this 1-to-1 ratio, Pb + 2, balanced by S -2. In the parenthesis goes the charge. This is known as lead 2 sulfide. How about letter C? Sn, that's the elemental symbol for tin. I'm going to leave the parenthesis open, and as we work to figure out the charge, that's what will go in. F is the elemental symbol for fluoride. So we have tin something. I have to work on that. Fluoride. Fluoride is a -1 charge. So what must be the charge on the tin to electrically balance 4 units of fluoride? So as I draw that out, I'm helping us visualize 4 separate F- ions. And I only have 1 Sn in the formula. Notice we have a 1-to-4 ratio, 1 positive. Well, that tin has to be 4 positives. Whoops. There, I have it back. 4 positives to balance the 4 individual -1s. This is tin 4 fluoride. Next one, PbO2. Oxide, we saw just a moment ago, is in group 6A. So I know that oxide carries a -2 charge. And do you see how there's 2 of them in the formula? So 2 units of a -2 charge. We have 1 Pb. Remember, Pb is our lead. I'm going to leave room in that parenthesis so that we can determine the charge. For every 1 lead, 2 oxides are chemically bonded. And the goal is to create an electrically neutral compound. Lead must be carrying a +4 charge to chemically balance the -2s from both oxygens. That's lead 4 oxide. Fe stands for the element iron. Fe is right here on your chart, so that's iron. I'm going to leave the parenthesis because iron has a variable charge and thus requires the Roman numeral. It's hooked to bromide. You see bromide here in group 7A, knowing that it's a -1 charge. See the ratio of negative ions. There's 2 units of Br negative bonded to 1 iron. The iron has to carry a +2 to balance the 2 individual -1s on bromide. Iron 2 bromide. You're doing good. Here's gold. Gold is Au. It requires a Roman numeral in its name. It has a variable charge. Let me leave that parenthesis open for a moment to include that in its name. Last name is chloride. Let's play detective and determine the total negative charge, and therefore, working backwards, we can find the charge on gold, Au. Chloride carries a -1. It's in group 7A. It gains one more electron to share the configuration with argon. So we have chloride, Cl negative, and there's 3 of them in that formula. 3 individual chlorides. Chemically bonded to just 1 unit of Au. It's going to require a +3 charge on gold to neutralize 3 individual -1 chlorides. The charge that it's carrying, gold 3 chloride. In your next set that you worked ahead on, these all had the same first name. They were Cu for copper. So I'm going to just get that written and make sure that I leave space in a parenthesis to indicate the charge that the copper is carrying. So we have to kind of play detective here and work backwards to find the positive charge that balances whatever it's attached to, a negative. So let's compare letter A, Cu2O. We know oxygen here in group 6A will carry a -2 charge. And notice that it has just 1 unit of a -2. Copper is just one of them, right? The subscript here is a 1. But I have 2 individual coppers. The subscript next to copper is a +1. Notice that it takes 2 coppers at a +1 to balance 1 oxide. So copper 1 oxide, Cu2O. But if you compare that to letter B, oxide, who's that -2, if I only see 1 copper in that, a 1-to-1 ratio of those ions, well, it was neutralized by copper's +2 charge. Copper 1 oxide, Cu2O. Copper 2 oxide, CuO. This allows me to emphasize the Roman numeral is the charge, not how many, right? So when I look at Cu2O, don't be fooled into thinking that that's the Roman numeral. It's not. It's telling me that I had a +1, 2 units of that +1 to electrically balance the -2. Letter C is attached to chloride as well as D. So let's compare the charges now for chlorides. Notice here I have a 1-to-1 ratio in letter C. Chloride is in group 7A. Gaining 1 electron makes it a -1 charge. So I have a Cl -1. And I notice that it's just being neutralized by 1 copper, right? That 1-to-1 ratio in the formula. So copper must be a +1, CuCl. However, in the next example, I'm seeing 2 individual chlorides with that ratio of 1-to-2. 2 chlorides, well, that's got to be balanced by a copper that's a magnitude of a 2 charge. It takes 1 copper at a +2 to chemically balance, electrically balance their 2 separate chlorides, each at a -1. Practice builds proficiency and it builds speed. The more we work examples, the easier they become, the faster you become. That's what proficiency and speed will do for test day. You'll finish on time and you'll finish correctly. All right, so let's keep practicing. Let's write a formula for tin, Roman numeral 4, oxide. The tin has the elemental symbol Sn. So I'm going to start by writing Sn. The Roman numeral indicates the charge, not how many you have, but the charge that it carries. That's a +4. Oxide is the element oxygen. We see that it lives in group 6A. Think what that means. 6 valence electrons, gains 2 more, giving it a -2 charge. When we crisscross, we have to write SN2O4. But that's not right yet, because a moment ago, remember that a formula unit must have the lowest ratio possible. That 2-to-4 ratio needs to be reduced. Cut it in half. A 1-to-2 ratio gives us the chemical formula for tin 4 oxide. How about sodium oxide? Now there's no Roman numeral there after sodium, but we don't need it. We know that sodium's a +1. We know that because it has a fixed charge living in column 1A. Sodium's elemental symbol is Na, and I know just by where it lives, it carries a +1 charge. I don't need a Roman numeral to tell me that. Here's oxide. We know it's in -2. When we crisscross, bring these around and down. Na2O1 simply becomes Na2O, sodium oxide. We're going to keep practicing. Here we have a mix of all binary compounds. Some of them have fixed charge, some of them have variable charge. That's why I see the presence or absence of a Roman numeral. Letter A is calcium. No Roman numeral after it, but I don't need it. I know calcium will be a +2 because it's in a fixed column of a +2 charge. Here's bromide. That's from the element bromine. I know that it carries a -1 charge just because it lives in group 7A. Bromine, with its 7 valence electrons, will add 1 more to become like a noble gas, making it a -1. When we crisscross, we bring our numbers around and down. Ca1, Br2. Calcium bromide, CaBr2. Calcium carries a +2 charge. Bromide carries a -1 charge. I can see that for every 1 +2 calcium, I am going to require 2 units of a -1 bromide, CaBr2. How about copper 1 iodide? Elemental symbol of copper, Cu. I wouldn't know its charge based on where it lives, so I see the Roman numeral. It's a +1 charge. It's chemically bonded with iodide. I, just like bromine, it's group 7A. So bromine, I'm doing iodide. I -1. Look at a +1 and a -1 is balanced. I don't need any further subscript, Cui. Ferric gives us the higher charge on iron. Ferric bromide I could name as iron 3 bromide, telling me that iron is a +3 and that bromide is a -1. I know that based on where it lives. Crisscross, bring these around and down. FeBr3, iron 3 bromide. Letter D, magnesium, who's a +2, sulfide, that's the element S, group 6A is a -2. That's 0 already. That's just simply MgS, magnesium sulfide. Chromium, +2, and chloride, -1, and we have a +2 -1, bring those charges around and down, CrCl2, chromium 2 chloride. Remember, repetition over and over and over for drill work, and we'll have these. I'll pause the video here. In our next site, we're going to invite more players on the field. We're going to talk about polyatomic ions and using polyatomic ions to create what are called ternary ionic compounds. So come on back when ready with your polyatomic ion chart, a tool page provided in your note pack.